Hey everybody, welcome back to Organic Chemistry. Okay, this is section 6. It's decarboxylation. And this is the last step before we wrap up this chapter and we learn about something known as multi-step reactions. Okay, so this is the last piece of the puzzle that we need to learn about. And then we're going to learn about something known as acetoacetic ester synthesis, malonic ester synthesis, and similar ideas. That's section 7. Okay, but this is a critical piece known as decarboxylation, all right? And it's something that you really need to get down well, so I want to make my own video just for this purpose, okay? That's how important it is. All right, let's go over it. Now, the first thing I want to talk about is the theory. And the theory of this, it's a very simple idea. Decarboxylation is the process of removing a COOH. You have to get a COOH to become CO2. That's the idea. That's what we're going to do. Now, obviously, if you're going to make carboxylic acid become CO2, you need a carboxylic acid, right? So that's the first thing. And so the idea of this reaction and how this works is that if you have a requirement of a beta double bond, then you can have a carboxylic acid decarboxylate. So here's what I mean. Notice that this carboxylic acid has an alpha beta relationship, right? It has a beta carbonyl. That's a beta double bond. Beta outward. As long as the beta carbon is double bond, then it can decarboxylate. And here's how it works. It's actually like a pericyclic or like a Diels-Alder type reaction. What happens is if you have temperature, then this oxygen, now keep an eye on this carefully, the oxygen on the right, the OH, becomes CO2. And that in turn only is allowed to happen because the alpha carbon can take the bond away from the C double bond O on the right and give it to the C double bond O on the left. So you're going to push the OH into becoming CO2, right? So this right here becomes CO2. And the only reason why you could do that is because there's a beta double bond. So the alpha carbon can give that bond, the single bond, over to the beta carbon, and the beta carbon opens up becoming O minus. But here's the thing, what about this H on the right? Where's that go? Well, the way it works is when this double bond O opens up, it actually hooks around and pulls that H. So what we wind up getting is an enol plus C double bond O, CO2. See that? Now enol, we know, can just tautomerize back and become keto. And that's how this works. That's how it works. Okay, now on paper, it's important that you see this because when they teach it in your book and in lecture, they always show it to you in a very fancy looking way. And it looks cool and yeah, it's great, but it doesn't help you on the way you're going to see it on your exam. They're never going to lay it out in that fancy way. So I think that the way that they'll show it to you in class, which I know that they do, is they go and they show it like this. They have like a like that. And what they say, see, this is the same thing. So here's my carboxylic acid, right? And all they do is they say, okay, this becomes double bond, this becomes double bond, this becomes single bond. And you get to that same result set. You get this plus CO2. Now, I think it looks nice. It's really cool, and how it flows around, that's really cool. But you can't see it like this because they never show it to you that way. If you're doing a synthesis or a reaction, you're never going to ever draw it like this, and they're never going to give it to you drawn like this. They're going to give it to you drawn like that. So what I want you to do right now, even though these two are the same exact ideas, right? They mean the same thing. It's just laying it out different on paper. I want you to be familiar with when it happens and what you essentially are going to do. So here, let me give you an example. If I have a structure like this, okay, carboxylic acid, and I have a beta double bond O, and I ask you what happens. Now, you can spend time setting this up the right way, but really, I'm going to tell you what the answer is. All you do is take your eraser and erase this right here, and that's the answer. That's it. So if you erase it, it becomes double bond O plus CO2. That's it. That's what happens. How does it happen? Well, just like I showed you, this becomes CO2, this goes here, this opens up and pulls that H, right? And so you get to this right here, plus CO2, and then it goes back tautomerizing, just write taut, right? Meaning that becomes double bond to the carbon, and this alpha carbon, remember I showed you a quick way to do tautomerization? You take the double bond and grab the H. So now the H is here. See that? That's all that's happening. But ultimately, that's the tautomerization. You make this double bond O, and then this H gets pushed over to here. And you get to that. But really, just understand that you're erasing a carboxylic acid. That is all you're doing. Okay? So, this is the process of decarboxylation. It's where you apply heat to do this. Now, let me give you some more examples because I want to make sure it's very clear, right? Obviously, there's ways that I can trick you, and I want to try that right now. So let's say I have a carboxylic acid here. I have a carbonyl here. I have, let's say, a carboxylic acid here. Okay? And I ask you, what's going to happen when you decarboxylate? So you're going to say to yourself, okay, here's a carboxylic acid, and here's a carboxylic acid. But notice that this one, alpha, beta, there's no double bond beta. So we have to ignore the bottom one. Nothing happens there. But notice that the top one, let's say in blue, here's alpha, here's beta. It has a beta double bond. So this right here disappears, and you're done. Just draw it out as if it wasn't there, and you get this right here as your answer. That is what happens, plus CO2. See that? So the requirement is a beta double bond O, right? Beta. So that's why the bottom carboxylic acid doesn't leave, right? That's another example. Okay, and again, you know how to do it with the electrons. You make this into CO2, you push this over here, this opens up and grabs that H, right? I'm not going to mess this up, so I'm going to erase all that, but you know how to do the electron flow. Okay, now there's a few things to point out, a few key points. A, if two carboxylic acids, only one decarboxylates. Okay, D means to lose, D, and carboxylate means carboxylic acid, lose carboxylic acid. So let's say I have a dicarboxylic acid, okay, like this, and I use heat. Here's the thing, once this one disappears, right, because it does that whole decarboxylation, so now we have a carboxylic acid on the left, plus CO2. Notice how you can't decarboxylate again, right? Why? Because this alpha carbon has no beta double bond anymore. So there's no beta double bond, right? There's no beta carbon. There's no beta anything there, right? But even if I did, if I had something like this, it would still be there, right? 3 carbons, but there's no beta double bond. So that's why you don't decarboxylate that, okay? So that's important to recognize. Even if you have 2 carboxylate, they don't decarboxylate. That's the first thing I want you to recognize. Okay, B. Any double bond works. Any beta double bond works. Okay, so for example, if I have, let's say, a carboxylic acid, and there's a double bond between, here's alpha, here's beta, so I need a double bond from beta somewhere else. So let's say it's beta double bonded to a nitrogen. No problem. It's going to work just fine. With heat, it becomes that plus CO2. Okay. By the way, there's an H here. That's why I was hesitant. I was wondering. Okay. So there it is. So what happened? Same thing as you expect. This goes here. This goes here. This opens up, right? But then it tautomerizes back. So initially you get to this, like that. This is the ene amine, right? This is ene amine. Okay. And by the way, this becomes NH2 because not only does it open up, remember how this pulls the H. So this pulls the H, right? And so you get to that, and then that tautomerizes back. How do you show tautomerization? Well, you can go like this, and then this guy pulls that H, and that's how you get it back to up above. But I'm not going to do that arrow because I don't want to mess it up. So there you go. There's an example, any double bond. Here's another example. So let's say you have a ring system. Here's a carboxylic acid, let's say right here. Okay? And there's a alpha, Not alpha beta double bond, but beta outward. So here's a double bond like that.